7.2 is going to be the one section that has kind of a trick to integrals beyond just your antiderivatives. And so recognizing it is going to be very important. It starts off with just your regular antiderivatives. It gives a formal definition to the indefinite. So remember, indefinite number one means there are no values. There's no order of integration. So if you don't have values, you just do the antiderivative and you need the plus c. Indefinite is just for all general antiderivatives. Okay, so example 1 is just using your antiderivatives. So recognizing if you see functions that are being added or subtracted, you just do each individual antiderivative. If it's a power, you just add 1 and divide. Trig, use your trig antiderivatives. The antiderivative of sine is negative cosine. So that changes the minus to a plus, and don't forget your plus c. So this is what we've been working on. This is nothing new. I'm going to save time if you want to. If you want to copy down all of the properties, these are the same properties that we have been doing. Notice it just kind of formalizes everything. We have the trig antiderivatives. You know the power antiderivative. If it's a constant, you can pull the constant out, plus or minus. Here's your exponents and logs. So if you want to have something all in your notes here, or if you want to even put some of this on your little cheat sheet that you've kind of created, this just summarizes all the antiderivatives. Okay, so just verifying. So when we have recognizing if it's u to the negative 1, that's just 1 over u. The antiderivative is ln of the absolute value. This, we've talked about this before. So this I'm not quite so important, I guess. Okay, so paying attention to the differential. This says f of x is x to the third plus 1, and u is x squared. Find each of the following antiderivatives in terms of x. So notice letter A is basically just f of x. So I'm going to replace f of x with what it equals. I'm going to take the antiderivative of f of x. So just add 1 and divide. Antiderivative of a constant is just x plus c. All right. So f of u. So let's think about this. If f of x is x to the third plus 1, what is f of u is u to the third plus 1, right? So we're going to do first this in terms of u. Antiderivative is just like what we did over here. It's just in terms of, u. Can't talk and write at the same time. There's just an extra step because they want this to be in terms of x. After you do your antiderivative, we just replace all of our u's with x squared. So x squared to the fourth over 4 plus x squared plus c. So if they want it in terms of x, you just need to make sure your final answer is in terms of x. All right, so notice here, f of u dx, see when this matches, we can just do our antiderivative. So let's think about this. F of u is u to the third plus 1 dx. We cannot do our antiderivative if this variable does not match this variable. So what we're going to do is now I'm going to substitute u x squared in place of, replace your u in terms of x because this variable needs to match. See, when we plugged in this one here, the u matched the u, so we could do our antiderivative and then substitute the x squared at the end. Here, you need to replace, you need to have these variables always matching this before you take your antiderivative. Now we do our power rule, add 1 and divide, and don't forget your plus c. So these are all slightly different depending on how the integral is set up to begin with. Okay, now this is getting into the main part of the lesson, learning the concept of u substitution. And I'm going to specifically call this u substitution. Okay, so the first thing I want you to notice is we have two functions being multiplied together. You use u substitution if you have two functions being multiplied or divided. Remember, adding and subtracting, that's the properties we've been doing, add and subtract. You just do each one separately. When it's multiply and divide, this is what is signifying to you, you need to look at u substitution. So our goal is we want to convert everything here into using u's. So it's going to kind of be like letter B, where we have everything in terms of u, do the antiderivative, and then substitute x at the end. Okay, so choosing your u is always the hardest part. I would look a couple of places. Number one, I'm going to say whatever you choose for your u, you need to see the derivative of that u somewhere in your original problem. A place you always look is in parentheses, in the exponent, or in the denominator. And you're going to get a little bit more comfortable as we work through this. So I'm going to choose u to equal cosine of x. Then what we do is take the derivative. We take the derivative of u with respect to x. Now, this will be the only time that I write du dx here, and you'll see why in just a minute. But we take probably one of the hardest things about u substitution, you will do derivatives and antiderivatives all in the same problem. The derivative of cosine is negative sine. So what we do, I want to just have du on this side. So what I'm going to do is multiply both sides by dx. This is the only time this is going to look this way. Typically, I'm going to go from this step straight to this step, but this is why it looks like this. Okay, so now our goal is to replace anything that has an x here with something from this side with u's and du's. All right, so I'm going to keep my integral. First thing I'm going to do is take my e to the cosine x. Let me do it this way to see if this helps first. I'm going to switch the order because when I'm multiplying, it doesn't matter what order I multiply in. Now, the e has nothing to do with this side, so I'm just going to drop down my e. Where do I see cosine x? Here. So I want to replace it with something on this side. Cosine x equals u. So I substitute u in place of cosine. Now, where do I see sine of x dx? Notice here, it's almost the same, but this negative, I don't see over here. So you can multiply and divide to manipulate. So I'm going to multiply both sides by -1. And so this now matches this side, so I can replace it with -1 du. Now, anytime you have something next to du, just put that on the outside of the antiderivative of the integral, because that's just a constant. Now we do our antiderivative, bring down the negative. Antiderivative of e to the u is e to the u plus c. Now we just replace the u with what u equals, so I get my final answer in terms of x. This is a whole lot of information, so just kind of take a big breath. We're going to practice some more and be patient. Okay, so remember what I said. Number one, you typically do within parentheses or within a grouping symbol, and the derivative of what you choose has to be in the problem. I'm going to look at underneath the radical as my u, 5 plus 2x to the third. Take the derivative. I only want u's on this side, so I'm always going to put my dx on the other side. The derivative of 2x to the third is 6x squared dx. Now, notice I have x squared and dx. What do we not have in this side is the 6. So I'm going to divide by 6. I'm just going to make that as a coefficient in the front, 1/6. Substitute. So the square root, I'm going to write that as u to the 1/2. This whole thing is my u, so I replace 5x, substitute your 5 plus 2x to the third with u, keep the square root as 1/2, x squared dx is du. Now, what's with the du? Don't forget your constant on the outside. So what we do is take a complicated problem, turn it into a simpler problem. Now take your antiderivative, bring down the 1/6, add 1 3/2, divide by 3/2, which is multiply by 2/3 plus c. Now, I would reduce this. 2 can go into 6 3 times. So this is really 1/9. U, I'm now going to replace with take the u out, substitute the 5 plus 2x to the third, substitute that back. Everything else stays the same. And don't forget your plus c. Everything on here so far has been an indefinite without the values. Okay, so there's only cotangent here. Nothing is being multiplied times the cotangent function, but there is no antiderivative to cotangent. So I want you to remember what does cotangent equal? So you might not remember. Think of tangent is sine over cosine. So therefore, cotangent is cosine over sine. Okay, so we are going to do a couple of substitutions. First, I'm going to replace cotangent with cosine over sine. Remember, whatever I'm taking the cotangent of matches from top to bottom. Now, if there's a denominator, you're almost every single time choosing the denominator because the numerator's connected to the dx, so the numerator's got to be your derivative. Okay, so I'm going to choose my u to be the denominator, sine of 7x. Now I'm taking the derivative of u. The derivative of sine is cosine dx, but we also have to chain on the derivative of 7x, which is 7. So this is really important. Remember, when you're doing the derivative, we chain on with multiplication. When we do the antiderivative, we chain on with division. So be very careful about that. Okay, so if we notice, everything here is in the numerator except for the 7. So we need to divide out that 7. All right, so let's plug everything in. I'm going to pull that 1/7 out front every time. 1 over sine of 7x is 1 over u. Then cosine 7x dx is my du. Now I do my antiderivative, bring the 1/7 over. Antiderivative of 1 over u is ln absolute value of u plus c. Now I'm just going to substitute my u back in as my final answer. All right, 2 more examples. Okay. I'm going to wait on this just a second. I want to deal with this in person. There's just a lot of different things we need to deal with this. So I want to talk about this one in person and give you guys time to ask me questions. Okay, so the last 2 things that we want to talk about, notice these are not indefinite. These are definite antiderivative or integrals because they've got values. That's going to be super important. Okay, so we have 2 functions to choose from, tangent and secant squared. You choose one that the derivative is the other. So I'm choosing tangent because the derivative of tangent is secant squared. All right. So notice secant squared dx is my du. Tangent is my u. Now, this is the important part. If you're doing a definite integral, when you change everything into u's, you also need to do what I call u numbers. If this is in terms of u, your numbers have to be u numbers. When this is in terms of x, these are x numbers. So the only thing you do, you take your values. So I'm going to take 0 and plug it into x over here, and that turns it into a u number. So tangent of 0 is still 0, so this stays 0 here. Pi over 3, though, tangent of pi over 3, so first of all, pi over 3 is 60. So this is your 1, 2, square root of 3. Tangent of 60 is square root of 3 over 1. So now we have square root of 3 in that spot. So the numbers have to be changed into u numbers just like we substitute u into everything else. The nice thing about this, when it's u numbers, you never go back to x. We're only going to deal with everything in terms of u. So antiderivative of u is u squared over 2. We don't need the plus c because this is a definite integral from 0 to square root of 3. Plug in the top. Square root of 3 squared is 3 over 2 minus plug in the bottom, 0, which is 3/2. So the big thing is, if you see numbers, you just need to use the u numbers. Okay, last one. So we see two separate functions. So I'm going to always choose my denominator. I don't know why I wrote that. So u is x squared minus 4. My du is 2x dx. Notice here I have x dx. I don't have the 2, so I have to divide it out and move it to the other side. All right, now we do our substitution. Notice the u, x squared minus 4, is in the denominator. I like to I don't like having anything in the numerator here. I like the du always to be at the end. Sometimes you'll see the du over u. I personally just don't like that. I like having a 1 over du and pushing that over. But we still need the 1/2 out front. We're going to plug in 0 in to find our u number. 0 minus 4 is -4. And then we're also going to plug in 1 squared is 1 minus 4, which is -3. So we're going to go from -4 to -3. Then we take our antiderivative, pull down the 1/2. 1 over u is ln of u from -4 to -3. All right, this is exactly why we need the absolute value when you're using ln. Because when we do this, when I plug in -3, we cannot take ln of -3, which is why we need the absolute value. Minus ln 1/2 of ln of absolute value of 4. So let's simplify. Now, first of all, do you see that I can just factor that 1/2 out? And this is going to be ln 3 minus ln 4. And anytime you have two different logarithms, if they're being subtracted, you can condense and divide the values. This is always what you would see for a multiple choice. This is you need to condense. You need to understand that you need to pull the 1/2 out and condense your two separate logs into one.